They will solve March monthly exam of mathematics, geometric. Question 1 shows the correct answer. The sum of exterior angles of hexagon equal space. You want to find the sum of exterior angles of hexagon. Hexagon, meaning polygon which has 6 sides equal length is here hexagon, or this sides not equal length if this hexagon regular. Then the sum of exterior angles, it will be 360 exterior angles, okay? But if you want to find the sum of interior angles in this hexagon, you must write the rule and subtract by 2, reduct by 180. In reverse to 6 minus 2, reduct by 180. It will be 4 times 180. It will be 720. It was interior. It was interior angle, but 360 exterior angle. Okay, we have the difference between exterior and interior. Then the result here will be letter B, because he won't find the sum of exterior angles of hexagon. Question number 2, the measure of interior angles of regular pentagon. Okay, question number 2, he won't find the measure of an interior angle of a regular pentagon. Regular pentagon, it's meaning we have 5 sides in pentagon, such that 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Then we can find sum of interior angles here by write the rule n minus 2 product by 180 in reverse to the number of sides. 5 minus 2 product by 180. It will be 3 product by 180. 3 times 0 equals 0. 3 times 8, 24. Write 4 and carry up 2. 1 times 3 equals 3 plus 2 equals 5. Then the result will be 540. 540 degree. Next example, question number 3. The sum of measure of accurative angles around the point, it will be 360. This angle here, we have a lot of angles connected about this point, then sum of them it will be 360 degree. Question number 2, the number of diagonals of a pentagon is what? Pentagon, we know pentagon has 5 sides. 1, 2, 3, 4, 5. And we want to find the number of diagonals. You must know the number of diagonals. A pentagon equals the number of sides. The number of diagonals equal the number of sides in the pentagon. It's a special case, okay? Or you can write the rule. This rule, we used it to find the number of diagonal. The number of diagonal equal n product n minus 3 over 2 in reverse to the number of sides. How many sides here? 5. Then the number of diagonal, it will be 5 product by 5 minus 3 over 2, and the result will be 5. Okay, then the number of diagonal, it will be 5. It's exactly the number of sides. Okay, you must know this rule. Use it for any polygon. To find the number of diagonal in a polygon, you must write this rule n product by n minus 3 over 2. But we have a special case in the pentagon. The number of sides equals the number of diagonals. Okay. Next question. The space polygon is a polygon that has at least one reflex angle. Called it concave polygon. The concave polygon is a polygon that has at least one reflex angle. We called it convex. Concave, okay? The concave polygon. The concave polygon. Towards question number 2, write this word, concave polygon. Like this polygon. Okay, we called it in this angle here reflex. We called it reflex angle. We call this polygon is a concave. Concave polygon is a polygon that has at least one reflex angle. Question number 3. The measure of exterior angle of a regular quadral, it will be what? We have regular quadral such as this. Okay, we called it regular quadral or square. If we have 3 sides, it will be equilateral triangle. If we have 4 sides equal, we call it square. In any regular quadral, here, such as that, it's 4 quadral. Okay, but we have 3 sides here in this polygon. He won't find the measure of exterior angle of regular quadral. It will be 360. We have square. Square we called a regular quadral. A regular quadral, it's meaning polygon has 4 sides equal lengths. Okay, or we can draw rhombus. But rhombus, all angles not equal in measure. So we must know regular, it's meaning all sides equal in length and all angles equal in measure. Then the measure of exterior angle of regular quadral, here it will be 90 degree. We want to find what? The measure of exterior angle. Exterior angle in the square, here exterior angle it will be 90, and the interior angle it will be 90. If you want to find the sum of measure, the sum such that question number 1, the sum of exterior angles here of a hexagon, which was what? 360. If you want to find the sum of exterior angles, but in this example he won't find the measure of exterior angle in regular quadral. Regular quadral is meaning square. Then the measure of exterior angle it will be 90 degrees. The result will be 90 degrees. Question number 3. In the opposite figure we have triangle and 2 sides parallel. He won't find the measure of angle B. Okay, we have A, B, and C, and we have D here and E, and this angle was 50 degree. He won't find the measure of angle B. We have 2 sides parallel, such that DE parallel to BC and DB, transfer of them, then measure of angle B will be equal measure of angle D, alternate angle. And he give us the measure of angle D 40. Then the measure of angle P it will be 40 degree again. And then we can find the measure of angle CAP. This angle he won't find the measure of it. We can find the measure of angle CAP by add 50 plus 40 and the result subtract from 180. Because in any triangle the sum of interior angle in any triangle equal 180. Then in triangle CAP, the measure of angle CAP equal 180 subtract by 50 plus 40. We can write 180 subtract the sum of them. 50 plus 40 it will be 90. The difference will be 90 degrees. Then the measure of angle A or CAP it will be 90 degree. Okay, the measure here it will be 90 degree. Next question, letter B. In the opposite figure we have ED, cut of BC in the point M, and we have two triangle here, prove that these two triangles are congruent. We have here two sides equality, and this side and this side. We have A, B, C, and D. And this point was M, such that in two triangle AMB and DMC, we have A give us in the example AM equal MD, AM equal MD, okay. AM equal MD, and MB was equal to MC, okay. Cancel this again. He give us AM equal to DM, AM equal DM, and CM was equal BM, and we have measure of angle EMB, it's equal to measure of angle DMC. Then the first triangle AMB is congruent to the second triangle DMC, so we can prove that EB will be equal to CB. That's number one. And what about number two? We want to prove that EB parallel to CD. Then we can prove that measure of angle A equal measure of angle D, then measure of angle A equal measure of angle D, alternate angle, then AB will be parallel to CD. We called it alternate angle, okay? Understood? We prove that EB parallel to CD because measure of angle A equal measure of angle D, and angle A and D we called it alternate angle. Then AB will be parallel to CD. Understood? It's the last question.